All right, guys. Has anyone completed the question yet so far? All right, let's wait some. Anybody else? Let's give it a second. All right. All right, so let us just check and see what it's supposed to be. So you should add another column to calculate XF, and to get XF, you're simply going to multiply the first column times their frequency, whatever you get to put in that column. So 1 times 2, we get 2. 2 times 2, we get 4. 3 times 11, we get 33. 4 times 11, we get 44. 5 times 12, we get 60. 6 times 7, we get 42. And 7 times 4, we get 28. And 8 times 1, we get 8. So next, what we do is just add up what we have in this column. When you add up those, you should get 221. So that would be the sum of all the values. So that the sum of XF. Now you also need to add up all the frequencies to tell you how many values you have in total. So in other words, the sum of the frequency give you 50, so it means that you have 50 values that you're adding up. So you're going to divide now the sum of Fx, which is the sum of all the values, divided by the sum of the frequency. So you should get 221 divided by 50. So your mean would be 4.42. Let me see the answer, those who have actually gotten that to be your mean. All right. All right, so very good. Very good. All right, so this is how we would calculate the mean of just a simple frequency distribution. Now remember that we can also arrange our data in a group distribution table. And so when we do it like that, the procedure to calculate the mean would be similar, but we would have to take into consideration now that our X values will now be in classes instead of just single X values ranging from smallest to largest. Now, so the range of these numbers, the smallest would be 1 and the largest would be 8. So when we refer to the range, we're looking at the smallest and the largest. And sometimes we would calculate the range using those numbers, the largest minus the smallest, to give it a range. Now look at this distribution. This is a group distribution table. And so we need to calculate the mean just as before, but now we're dealing with classes instead of just single X values, all right? Now, for each class, we need a single value to represent the class. So from the class, we need to come up with an X value. So this is our class, and the class values go from 150 to 154. But of course, we just need only one value representing this class. So what we generally use is the class midpoint. Anybody remember how to calculate the class midpoint? the middle value of this class. Ms. Cavero, how do we calculate the class midpoint?
Sir, you add them up, then divide by 2.
Correct. So to get your class midpoint, you just add the two values, two limits, and divide by 2. So of course, you're going to have to construct a column for all of those class midpoints. All right, so so when we're doing the frequency, not the frequency, when we're calculating the mean for this, we have to add a column for your class midpoint. We will now add another column for your XF. All right, so in the first column that we would have created here, so this column, we would now refer to it as the X values, right? But remember that this X value actually going to be what? Your class midpoint values. So it would be the class midpoint. All right, so the class midpoint values will go in that column. And this column now will still have this column as your X times your frequency. So you would still go ahead. So what you'd have to do, calculate all of your class midpoints. Then you use your class midpoint value to find your XF. And you add up all of those as before. To get the sum, you add up all your frequency. And then now you divide the sum of XF divide the sum of XF by the sum of the frequency. All right, so our first class midpoint value here would be, you add 150 plus 154 and divide it by 2. Your class midpoint here is supposed to be what? 152? All right, so all your...
Which one you're doing, sir?
For the first class midpoint for the first class is 152.
Okay, yes, sir.
Right, so I'm saying that all you need to do now is do the calculation for all of the other classes and put them here. And then now you find XF, you multiply your class midpoints by your frequency, and you will get the value for XF over here. All right, so I'll give you another 5 minutes to work this out. And you raise your hand and just state what you get for your frequency, for your mean. All right, so I'm giving you about 5 minutes to do this. Go ahead, guys. All right, have any? Is there anybody who actually completed the question? Let me see the hand up.
Yes, sir.
Anyone who have completed? All right, anybody else? Let me see your hand. All right. All right, so let us look at what we have. So for the class midpoint values, I would have done the first one. And so your task was to complete the rest of that column with the other class midpoint values. Now, the general rule to calculate the class midpoint values, you add the two values of the class. We call them lower and upper limits. So the lower limit is 150, the upper limit is 154. So if you add both limits of the class and divide by 2, you'll get the class midpoint. Now, there's also another way you could calculate the class midpoint, and pretty much that should be a little faster than just adding them and divide by 2. So generally, if you look at all the classes, if you take away the smaller number from the larger number for all the classes, you realize that all the classes are different only by 4. So if you take away 150 from 154, you see you get a difference of 4. Now what you do, you split that difference into 2. So you divide 4 by 2. So when you divide 4 into 2, you will get 2. Now, all you have to do to get all the class midpoints, our left column, all of the limits from the left column, is simply going to add that 2 to each of them. So 150 plus 2 give you 152. Then 155 plus 2 give you 157. 160 plus 2 give you 162. 165 plus 2 give you 167. 170 plus 2 give you 172. All right, so that would be a much easier way to calculate your class midpoint value. Is that clear, guys? Let me see the hands of those who understand what I just did. All right. Having calculated your class midpoint values now, all you need to do is just simply multiply your class midpoint times your frequencies, and whatever value you get for those, you put them as their XF values. So let us hear the XF values that you get from your calculation, and let's see if everybody's on the same page. Ms. Cavera, what's your first XF value?
I didn't reach that part, sir.
All right. Ms. Cox, your XF value would be for the first?
Sir, the first one is 1,216.
1,200.
And 16.
All right. So that's the first XF value. Can somebody confirm that that's what they get to as well? All right. All right, Miss, who else now would have done it? Mr. Campbell, have you done your second XF value?
Yes, sir. I got 2,512.
2,512. Can anybody confirm that that's what they get to as well? All right, correct. Ms. Wilson, what is your XF value for the third one?
6,966, sir.
6,966. Anybody else can confirm? Can anybody confirm? Okay, one person. All right, Ms. Cox, what you get for the next XF value? Give me a second, guys. All right, guys, sorry about that. Who else with the next value?
Sir, 4,843.
All right, 4,843.
Yes, sir.
All right, so you have, who else can confirm 4,843? All right. All right, who got the next value? Last value?
688, sir.
All right, so you got 688. That's 6,000 or just 600?
688.
Okay. All right, so what you get for this sum now for XF, Miss Cox?
Sir, 28,135.
Can anybody confirm that? 28. $100 and how much? 35.
135.
Okay. Is there anybody else?
Sir, I got 16,225.
All right. So Miss Some got 16,225. Anybody?
Sir, I got 16,225.
All right. So all right. So we have two different values here. We're going to check them shortly. What you get for the sum of the frequency?
100.
So sum of F is equal to 100. All right, now make sure when with your checking, you take the time out to do your calculation and check it more than once so as to get the correct value. All right, so this is what you guys would have gotten. Some persons got a different XF. So I'm going to actually look at the solution table now and then see who is correct. All right, so I'm going to clear all of these. So our solution table will look like this. And clearly our XF value is supposed to be 16,225. All right. So who would have got the 28? Who was that person who got the 28? thousand.
Sir Cox.
Okay, all right, just check on check and see which of your excess value would be off. Or check and see if you actually miss out anything or add anything when you're doing your calculation, all right? And so you would divide the sum of XF by the sum of F. So that would be 16,225 divided by 100. So your mean would be 162.25. All right. So everybody should at least know the procedure of how to calculate your mean using a group distribution table. All right. All right, moving along. Now, there's another way to calculate the mean, not just this way. You have like two other ways that we could use to calculate the mean. Now, it's supposed to make your calculation easier. However, for some persons, you will probably don't agree with that, all right? Because it involves you creating another column. You would still have to find your class midpoint value. You still would have your frequency column. Now, instead of having an X of X column, you would have a difference times F. All right. Now, the difference column, as you notice here, we'd have to work out a difference column. Now, the method that we're using here is the method of the assume mean, right? Now, this method, what we generally do when we're doing the assume mean method, and we always take out one of the class midpoint value, any one of them. We just choose it and assume that one of them is the mean. So you choose one to be your assume mean. Most of the time, it's better to choose a value it's somewhere in the middle of the class midpoint values, so that you will have a balance in terms of negative and positive mean difference. All right. Now, when you choose your assume mean, let's say you choose 162 as your assume mean. Now, what you're going to do with that value that you choose as your assume mean, you're going to use that value to calculate your mean difference, which is labeled as D in this column. Now, these values that you get here, you would have to subtract your assume mean, which is the 162, from all of the class midpoint values. So in other words, you would subtract 162 from this value. So whatever your assume mean is, you subtract it from all the values. All right, so clearly, after you do the subtraction, then you're going to write those values in this column. So if you take away 162 from 152, you're going to get negative 10. 162 from 157, you get negative 5. 162 from itself, you get 0. And 162 from 167, you get 5. 162 from 172, you get 10. Now, the rationale behind using the mean difference, if you notice when you were doing the mean without the difference for the group distribution, you would have to be calculating values that would really add up. When you calculate those values, you get some large values, right? And when you're working with large numbers, especially when you're adding, you're likely to make mistakes with those values. And once you make you have made a mistake, you're going to throw off your answer, right? So the rationale behind using the assumed mean value is that you will have smaller numbers to work with when you're actually calculating. All right, so here now, we are just going to multiply our frequency time our mean difference. So we would have, for this mean difference, it would be that you use 8 times -10, and that would translate into -80. So we have 16 times -5, and that would give you -180. You have 43 times 0, and that would give you 0 for your difference time frequency. So you have 29 times 5, you get 145. 4 times 10, you will get 40. Now you would add up all of your frequency times the difference, or the different times your frequency. When you add up all of these, bear in mind that you're adding negative and positive numbers, so you have to obey the laws that you learn for adding negative and positive. All right, so if you're adding unlike signs, you find the difference, keep the sign of the larger one. So when you add up all of this, your sum for your difference times frequency equal to 25. Now, notice that this is a very small number. Now, you're going to divide this by the sum of your frequency. So you're going to add up all the values of your frequency. You will get 100. You will divide the 25 by 100. You get 0.25. Now, this 0.25 is what we call the mean difference. So that's a difference that you would have from the assumed mean. So if this gives you the difference of the mean, then that means the actual mean is when you add this value. You have to now add this value. You have to add your mean difference to your assumed mean to get the actual mean. All right, so the actual mean would be 162 plus 0.25, which is 162.25. All right, let me see the answer, those who are following so far and you understand what I'm saying. All right, now using the assumed mean method is an option. It doesn't mean that you will have to use this method. You can use the other method that we have done before this one, right? And you will pretty much get the same answer. But this method, it works well when you have a lot of numbers and you're working with large numbers, because sometimes your data values may be more than just in the range of 1,000 or so on. You might have data values that ranging in like 25,000, 30,000 or 1,000 or so on. In that case, you may want to find your mean difference so that you can work with smaller values instead of those larger values. All right, so you actually get the same answer as before. Any question, guys? All right, so as before, you see you would have the same